Hey guys, thanks for joining. And this time we will be going through complete workflow that starts with step file, loads that into the FreeCAD, and well, if you know step, you know that it's based on BREP geometry, and we will be creating glTF file at the end, but there will be some intermediate steps that are quite important to understand, and I will be explaining the process behind it. So usually what you get when you have a step file is the model like this. I'm really happy that Ironside Armor was able to provide me with the model, and they allowed me to use it in this tutorial. It's not a very complex model, of course, but it represents the issues that people face quite well. First one is, of course, grouping objects in logical order so that everything is optimal, right? In game engines on the web especially, it's very important that you don't overuse the amount of meshes. Thus, we want to keep the amount of meshes that we generate from such a model to the minimum. And to do that, actually, it's best to just group them by materials. In this case, I will just use color to group the objects into logical sets, right? And each color represents a family of objects that will land into separate meshes, and you can then also choose different kind of tessellation options for those meshes. But let's just start and see what I mean. What we have here is just the model, right? It's a dip station. It's part of basically gym equipment set that the company is selling. So the first thing that I will do is I will select this face, and then I will open this macro editor. I will select the macro to select by color, and I will execute it. You will see that now I have selected quite a lot of inner objects in this assembly. And what I will do is I will go to the mesh workbench, and I will say that I want to create a mesh from the shape. I will click this button. And now I already adapted the parameters here for my personal needs. You can choose different kinds of parameters based on your models. But what I will do is I will say, okay, I'm fine with these options. And now we can just close this dialog here. Let's scroll up. Let's close this one. So we generated a lot of meshes for each part, but what I want to do is I want to merge all of these meshes into a single mesh, because that will render much faster in the game engines on the web. And let's use this button here. So you see that it is called merge, and let's click it. So now you see that all of these individual meshes were merged into a single mesh, and we can just delete this mesh. So now you're left with one mesh object, and I will just call it satin because I know that it's the material that I will be using in Blender later on. So basically I'm merging those objects based on their material, individual characteristics, because if you want to apply two materials on a single mesh, that becomes quite difficult, and it's better than to not do that. So in this case, we already have one material, satin, and one mesh that represents it. So now I will select this face here, and I will execute my macro again. So now I've selected all of these parts. I will just do the same thing. I will just tessellate them. I'll say okay. Now I will hide this. And again, we just merge everything together into a single mesh and delete the in-between meshes. So these are called rubber. I know that I will be applying a rubber material on those. And we will be doing that for all of the parts basically. So I did find the macro online, I mentioned that. So this is the forum entry which I've used to find the macro, which allows me to select objects by color. And you see here the user Roy043 is replying to the request with this macro. And this macro I've just copy pasted into the macro editor in FreeCAD and used it to select the objects. I will also make sure to include this macro in the description of the video so you can find it easier. And of course, I will give credit to this user. So let's move on, and you can go here and see how it looks like. So this is just a Python script that selects all objects that use the same color. You can of course use different methods to group your geometry in BREP files, so in step files. But yeah, I found the colors to be quite nice approach to this problem. So I'm not a big expert in FreeCAD or Blender, but I do understand what is required, from glTF files to perform well on the web. And of course, you can find different ways to group those objects. Maybe you will use some sort of higher level attributes or whatever to find your geometries. But for me, this color approach works quite well. And let's go further. So now maybe it's also a good idea to hide these meshes. And let's continue. I will select this face and I will execute the macro again. Execute. I select everything that is stainless steel. Let's tessellate that. Let's close it. Let's go down. Here we see 3 objects, and let's merge them together in one. Let's delete the objects. Let's call it stainless steel mesh, and let's hide that as well. Let's execute the macro. Let's tessellate. Okay, again, merge those together. Let's delete those. Let's call it gray steel. So I know that they will be using a different material as well. And the last thing that I want to merge is this one. So let's go ahead and execute the macro. Let's tessellate. Okay, merge and delete the originals. So what you see me do here is maybe an overkill. I just merged 2 meshes that are separate, but the more meshes you have, the bigger performance gains you will get. We had some models that had like 1000 individual meshes in them, but they share the same material. And each mesh, in the game engine on the web, it requires additional drawcalls, which drops FPS, like frames per second, quite substantially. So you really need to think about performance when you build configurators, when you're preparing the files for these configurators. So that's why I'm showing you, how to merge those into a single individual meshes per material so that you could optimize your models to the max. And of course, if you have a lot of materials, the performance gains will probably be smaller, or you may need to find another ways to deal with that. Sometimes you can use maybe sub-materials, complex meshes, and all kinds of things. But yeah, in this case, it's just logical to do it this way. And let's continue. Let's now call this knurled. I know that this will be knurled material that we will be applying to these 2 meshes. And that's it. So I hope that I've created everything. To check on that, I can just enable all the meshes and then, just hide this dip station object. And let's see if nothing weird happens. Yeah, looks like everything is in their place after I hide it, right? So I consider that we sort of got everything working. And you see that from all the sides, the model is okay. Looks good. So I think we have all the meshes. So now what I will do is I will be using PLI format to export these meshes into. So what I do here is I say satin. So now I will be clicking this button to export the satin model. Here I will just choose PLI format. Let's find that one. So here. You can choose whatever you want, but I know that Blender can import PLI files just fine, so I'll use that. And let's hit save. And let's do that for other meshes as well. So export that. Let's choose PLI, save, stainless steel, export, PLI, save, gray steel, export, gray steel, PLI, save, and knurled, export, PLI, and save. So that's it. On FreeCAD side, we're finished. We now meshed the model and it's time to get it into Blender now. Sorry to interrupt. In case you don't know me, I'm Matas, the founder of Bit by Bit. I hope you enjoyed this video, and if you do, please hit that like button and subscribe to our YouTube channel. I also want to offer you a small deal. Because you're watching this video, I assume that you're using Bit by Bit platform too. Here's the promo code that will give you a small discount to our silver and gold plans. With these plans, you gain access to our cloud infrastructure, 3D configurators, and other advanced features. Your subscription also helps me develop the content, such as this video that you're watching right now. It also helps me develop Bit by Bit platform and keep majority of its features free and open source to everyone. Your support means a lot to me. I hope you'll consider the offer, and let's continue with the video. Okay, so I'm in Blender. I've created a new file, and the only thing that I have in this file are materials. So I just opened a file that contains all the materials. I deleted that model, and materials remained in the file, and I will use those same materials to apply them on the meshes that we will be importing. So you see that here everything is empty, and I will just hit import here. So import PLI. So we just select all the PLI files, and I will use 0.001 scale. Up axis is Y in our situation, and forward is Z, so this is all fine. And let's hit import PLI. Here is our model, so it's all gray, no materials were applied to it. And what we will do is we will be applying the materials. So first thing is quite simple. We can just pick this object, right? And I know that we need to go into this material properties tab here, and I can just click here. And I know that I have to use this satin material here. So these are Italian names because the client is Italian. And yeah, just don't pay too much attention, but this is the right material to use. Then I know as well that this object needs to use the gomma material. It's for rubber. And because these are, rounded shapes, we can also use smooth shading. So just click right mouse button and select shade smooth. Now it will look somewhat better, right? So because this part is flat, it's better to keep it on flat shading mode, and we can use smooth shading on these parts as well. So shade smooth, you see that then all of those edges disappear from the model. These should also use smooth shading, and these I'm not exactly sure because of the plate, which is flat. You could also group those meshes based on their roundness and decide to have these into a separate mesh, but in this case we just group them by material. So let's then pick one solution for both, and let's see. So let's click this inox, so stainless steel. Doesn't look very good on this part, but let's see if it looks good with smooth shading. Yeah, so smooth shading messed this up, and flat shading messes the rounded shape, but I think in this case let's leave it like this. This is just better, and from further away it doesn't make much difference anyway. And these are just gray steel material, so it's, let's see, this one, grezzo. Okay, so this looks good on the ends, right? And this part is more tricky because it's using a knurled material. And if I apply the knurled material, it's, which one is it? This one, inox knurled. You'll see that it doesn't really do anything. It's just a sort of metal color. So what I will do is I need to edit the UV textures a little. I'll move myself back here. So let's do it. Let's go into this UV editing mode. I'll zoom in again. I will also try to, let's see if I can reach it somehow. Yeah, let's make this part smaller. Let's go into the wireframe. What I will do is I will also hide everything that I don't need in this case. So let's just keep this knurled part active. We have to unwrap them. And to do that, I will just, choose the image that shows some normal information here in the image section. And I'll just choose all of the faces of this. Let's see. I suppose we have everything here. And what I will do is I will just go here, unwrap faces, and I say that I want to do the smart UV unwrap. I'll just unwrap that. Yeah, this is not ideal. I think we'll see some issues, but yeah, I'm not a big expert in unwrapping, so just forgive me for that. I think it will help. You see that, yeah, the material is applied. The scaling is not correct, but we will fix that in a minute. And for this mesh, we need to do the same. So let's maybe go into wireframe again, choose it. Yeah, everything is selected. Let's do the same. UV unwrap, smart UV project, unwrap. And yeah, this one looks better, I think. Not exactly sure how that is different from this one, but apparently it's just easier to do it on this one. So anyway, let's move on, because yeah, I really don't want to spend too much time on this part in this tutorial. Let's go into the layout mode again. You see that now they don't look very nice, but what we can do is we can go into shading. And I know that here we just need to fix some scaling issues. Let's zoom into, yeah, maybe let's go into view, frame selected. Yeah, that's better. And now what I will do is I will just apply 1, 1, 1, and here as well, 1, 1, 1. And you see that the knurling pattern became better. I guess we have to use 3, 3, 3, and here as well, everything's 3. Okay, so knurling sort of looks better, I think. I mean, you may see some issues if you inspect it probably from really close by, but yeah, this works really well for the model, I think. And we can now enable these meshes again so that we have complete model. And because we now have complete model with all the materials applied correctly to it, we can export to glTF file. And to do that, we'll go here into the layout mode, we'll hit export, and we will be exporting to this tutorial folder. I will say that I want to name it dip station GLB. We don't need to export animations in this case. We also don't need shape keys, skinning or whatever, and we will not be compressing this file. So this will save uncompressed binary glTF file, and we will be compressing in a different step of the tutorial. So transform is correct. Let's say that we want to export selected objects, and let's just select the meshes that we've created. So these ones. That's okay. And now let's hit export. So now we've exported glTF file, and we will move on into a different step of the tutorial where we will be compressing this file. Okay, so in order to compress this file, we will go and we will drag and drop this dipstation GLB file into a Khronos compressor. So Khronos group is a web standards group that created this tool. And I really enjoy using it because it's quite simple and it offers some nice features that we will see in a minute. So we opened our glTF file, and first thing that we want to do is we want to look if the model looks good, right? So we will inspect a little bit the materials and everything, and I think it looks great actually. So what I will do now is I will hit this compress button here, and we have two options here. So we have a geometry compressor and we have texture compressor. Both of these are really important to us in this case because we want to compress both geometry and textures. And you see that we have some textures here and we have some geometry here. Another thing that you will see is that the materials that we've used are quite heavy, right? And we don't need those to be that big. This one as well, you know, it's way too big, like 2048 by 2048. You will see that we can see the results of the compression after we hit compress, But first, let's go into this geometry compressor. Let's click this scene so that we select everything in it. And then you have to use Draco compression because 3D Bits app for Shopify can decompress this compression algorithm really well. And here you have additional options. I usually just leave those intact. They work really great, so I don't really think that you have to optimize it too much. But you can here optimize for speed, you know, for compression speed or for decompression speed, whatever you prefer. So we will not change settings here. So go into the texture compressor and say that we want to compress all of these images. And let's for now not use KTX2, let's just use JPEG. And also let's choose 4x downsample. Basically here you can also say how good the quality of JPEG should be, but we can now hit compress and you will see that we've got this division line here. And if I zoom in, you will notice probably if I zoom even closer that the quality of this side is a bit worse than that one. But if you look at the same object from, you know, some logical distance, then you don't really see the big difference. And I think it's fine. What we did, basically we compressed from 1.5 megabytes to 0.47. And that's quite a big win, right? Because these are then way more efficient models and they will load much faster. And sometimes if you compress, you know, huge meshes, the performance gains will be even bigger. So let's export this as glTF. Say that this one is compressed. And we can then also just inspect to make sure what are the performance win. So 1.7 megabytes and the compressed variant is 500 kilobytes. So that's quite an impressive improvement, right, for 3D model. It's not an image, so it does weigh a bit more maybe than the JPEG itself, but it's not that much bigger, right? And yeah, it looks still quite good, I think. So now that we're done creating this optimized file, we can upload it here into Shopify file system. So I'll just hit this. Now it's being uploaded. You see it being processed here in the corner. And let's move me back here. Let's wait a little. And now it's finished. And what's nice from Shopify is that you can open this file here and you can look into it. Of course, the texture looks messed up, so it didn't pick up some of the properties of the glTF file. Maybe the compression didn't really work well, but I think in general in 3D Bits app it will look great. So let's go here into 3D Bits app. I will just make this somewhat regular size. Let's go into this viewer editor. What I will do now, I will just add the model and I will copy paste the link here. I will name it a dip station here. And I will also hit this update button now to load it in. You see that it's loaded, but it's quite small. And the only thing I want to do is actually change how big it is. So maybe let's use scaling of 10, for example, and hit update. So now it's somewhat bigger, right? It looks a little bit better. Of course, if you zoom in, it's quite gray and it has no lights yet, so there are no shadows. To change that, we can go here and let's add the skybox configuration. Let's just use a default or, you know, maybe the city environment. It's a similar that we saw in the Khronos compressor. And let's update the model now. So you see that it looks already somewhat better, right? Maybe I will increase the scale just a little bit more, like to 20. 20, update. So you don't need to, at the end, do this, I think. But yeah, you have to just adjust it if you don't like it. So it looks quite a bit better, and maybe the only other thing that I will do is I will just add one directional light and I will increase its intensity to 3. I'll hit update and now you'll see that the model received some shadows here and it looks quite nice. So with this I will end the tutorial. I will not go further into steps that would load it into the product page. There are other tutorials that show that, but basically we're done now with this particular tutorial. So I'm really happy to have found some time to really film this tutorial. This process of going from step files with BREP geometry to glTF isn't really well documented on the web. There are many approaches to do it. The one that I've used is definitely not the best maybe, but at least it offers a solution, and quite optimal solution. Especially this method is useful if you have a lot of meshes, so merging those parts is really beneficial for performance. We already saw one part which we downsized to 6 meshes from 1000 meshes, and performance really improved. The frame rate of the configurator increased substantially. So this is really important to get right, and you can do it differently. You can join meshes maybe in Blender together. Sometimes it works, sometimes you will find your own solutions to this problem. I'm just presenting you the pathway by using some open source tools like FreeCAD and Blender, and I think those are really great. So yeah, I hope you will find it useful as well, and you may use it in your own workflows. So till next time, I hope you enjoyed it. Please subscribe to our YouTube channel and use 3D-Bits app for Shopify to sell your products. Let's see each other in the next tutorials. Cheers, guys.